digital signature. So we will study hash functions and what are the applications of the hash functions. Then we will see one more application of the cryptography that is in pretty good privacy, that is for secure email communication. Then we will see the implementation of the cryptography for the IPSec protocol that is used for VPNs. And then we will have what principles of cryptography are used for the digital signature principle and how this digital signature works. Okay, so now let us proceed forward. So first it is your hash function. So as I have told you in my previous lecture also, there is a message or data block of variable length, and there is a mathematical function called hash, that is a h, that is a hash function, and that converts this message or data block m to a hash value h of fixed length. Okay, so we get a fixed length output. Okay, so as I've told you, the property of this fixed length output is that even if you change a comma or full stop in the original message, the hash value will change. And this hash value is irreversible also. That means you cannot generate the original message from the this hash value. Again, if the message is different, then that will not give the same hash value. It will always give you different hash value. Okay, so the hash value represents concisely the longer message, may be called the message digest. Message digest is a digital fingerprint of the original document, and this hash function is a mathematical function. Now let us see difference between hashing and encryption. So suppose this is encryption. You are having a message, you are encrypting it using an algorithm. Then there is a key also going with algorithm, as I have told you in the cryptographic part, and you are getting a mangled text or the text which you cannot read, or you cannot gain a meaningful information out of that. And now this is the decryption phenomena. This is the ciphertext. Now you are allowing the reverse of the algorithm, that is the decryption algorithm. You are taking key as input, and now you are getting the plain text. Okay, so you are able to get the plain text from the mangled text by the decryption principle. And in the encryption principle, from the plain text, you are obtaining the mangled text or the ciphertext. And again, in the decryption principle, from the ciphertext, you are able to obtain the plain text. Okay, now hashing is one way. There is no dehashing. Suppose this is the text message, you are putting it to a hash function, and now you are getting a message digest. If you see here where my cursor is moving, you are getting a message digest. But if you want to reverse, means you want to get this message from this message digest, you will not be able to do this because there is no dehashing as like decryption. So this is the basic difference between the encryption and the hashing. That hashing is irreversible, whereas in the encryption, from the ciphertext, we can obtain the original plain text. Okay, so what are the applications of the hash function? So used alone, it can be used for file integrity verification. Means suppose you are having a file, you generate a hash value of that, and now you keep hash value with you, and later on when you check the file, you again generate the hash value, and if the hash value changes, that means somebody has changed this file. Similarly, for the public key fingerprint also, so that if nobody has changed this public key, for this also it is used. For password storage, this hash value is used. For the hash message based authentication, HMAC, this hash is used. And in the digital signature part, we will see in the later part of this lecture, we will see how this hash function helps in creating a digital signature. Okay, so as I've told you, with hash we can have a integrity checking. So suppose this is your current message, you are having this hash function, you are calculating the current digest, and now you have a previous digest of this message. So now you are comparing with this, and if the message is if both are same, that means the message has not changed. But if both are not same, that means message has changed. Okay. And similarly, for intrusion detection and virus detection, we can have a hash generated of the virus signature, and later on we can match with this hashes with a virus which comes, and we can detect that which virus is there in our system. Now, it is also used for password verification. If you see here, suppose you are storing your password in a password file. So suppose you are giving this as a password. Now this will go to a hash function. This will calculate a message digest, and this will be stored in a password file. Okay. Now, when you want to log in, how this password will be verified? Suppose you are logging and you are giving your password. So that will pass through a hash function, and a message digest will be calculated. Then this message digest will be matched with the password hashes stored in the password file. And if the match is found, that means you are a valid login user and you will be granted access. And if no hash matching is found, you will be denied access. Okay, so this is your password. This is the application of the hash functions in the password verification. There are various hash functions family. The first is your MD, message digest. It is designed by Ron Rivest. Family is MD2, MD4, MD5, and now this is not considered as a secure hash function because it has been compromised. The next is your SHA, that is secure hash algorithm. It is designed by NIST, and the family is SHA0, SHA1, and SHA2, and it is considered secure. Then next is RIPMAN, Race Integrity Primitive Evaluation Message Digest, and the family is RIPMAN 128, RIPMAN 160, RIPMAN 256, RIPMAN 350. If you see a number here, it is giving us SSA 256. So this is the size of the message digest. This is the bit size of the message digest that will be produced out of these hash function. For example, SSA 384 is there. So this is the bit size of this SHA algorithm that will be produced out of this. This is SHA 5 and 12. So it is the means bit size of the message digest will be 512. Similarly, RIPMAN 128 will produce a message digest of 128 bit. RIPMAN 160 will produce a message digest of 160 bit. RIPMAN 256 will produce a message digest of 256 size, and RIPMAN 320 will produce a message digest of 320 size. Okay, so now let us come. So this was all about the hash function. Now let us come to PGP. Okay, so what is PGP? So pretty good privacy, or PGP, is an encryption system used for both sending encrypted mails and encrypting sensitive files. Since its invention back in 1991, PGP has become the de facto standard for email security. Okay, so this is for secure email communication. Okay, PGP is mainly used for secure email communication, and its full form is pretty good privacy. Okay, so the popularity of PGP is based on two factors. The first is that the system was originally available as freeware, and so it spread rapidly among users who wanted an extra level of security for their email messages. The second is that since PGP uses both symmetric encryption and public key encryption, it allows users who have never met to send encrypted messages to each other without exchanging private encryption keys. So as it is shown in this slide, that it is popular because of two factors. The first is that it is available as a freeware, and the second is that it uses hybrid cryptography. As I've told you, it leverages the benefit of both the symmetric encryption and asymmetric encryption, because it uses asymmetric encryption. So anybody can use this because they have a public key, and using that public key they can communicate, because everybody's public key is available widely through public key infrastructure to anybody. So anybody can communicate with anybody using this public key cryptography, and during this they can share a session key, and that can be used for bulk encryption during their actual data transfer. Okay, So the PGP shares some features with other encryption system, and that is Kerberos encryption, although we have not covered Kerberos encryption, but we have seen just before this session the SSL encryption. So it is based on the same principle, that is your cryptographic principle, and it is also based on hybrid key cryptography, that is it uses both the principle of asymmetric key cryptography as well as symmetric key cryptography. Okay, so at the basic level, PGP encryption uses a combination of two forms of encryption: symmetric key encryption and public key encryption. Okay, in order to understand how PGP works, it is useful to let us look at a diagram, and this is the diagram. So how PGP works. Okay, so now suppose user A wants to send user B a private mail. Okay, so user B generates a public and private key. User B keeps the private key and sends back the public key, or it will not send back, it will distribute this public key through the public key infrastructure. So the public key of the user B is available at the public key infrastructure, and anybody can access it, and anybody who wants to communicate with B can communicate through its public key. So user A encrypts their message using the public key of B. User A sends the private encrypted message to B, and now since the private key corresponding to that public key is with the user B, so user B decrypts the message with its private key and reads this message. So in a similar way, if B also wants to send a encrypted message, so B will pick the public key of A from its public key infrastructure, and now B will encrypt the message using A's public key, and it will send the message to A. And since A has only the private key corresponding to that public key, so A will be able to decrypt that message. And in this way, a secure communication will flow between A and B. Okay, so this is at the highest level. This is how the PGP encryption works. So first so let us see how this works. So first, PGP generates a random session key using one of the two main algorithms. This key is a huge number that cannot be guessed, and it is used only once. Once this session key is encrypted, this is done using the public key of the intended recipient of the message. The public key is tied to a particular person's identity, and anyone can use it to send them a message. The sender sends their encrypted PGP session key to the recipient, and they are able to decrypt it using their private key. Using this session key, the recipient is now able to decrypt the actual message. Okay, so since public key, as I have told you, public key cryptography is much slower than symmetric encryption, where both the sender and the recipient have the same key. So using symmetric encryption requires though that a sender share the encryption key with the recipient in plain text, and this would be insecure. So by encrypting the symmetric key using the asymmetric key public key system, PGP combines the efficiency of symmetric encryption with the security of public key cryptography. And that I have told you, that the session key will be shared using the asymmetric encryption, and that session key will be used for the bulk encryption. So this is how this PGP also works. And as I have told you, this hybrid key cryptography is used because we have to leverage the benefit of both, that is public key cryptography, that is multi-communication, and we have to leverage the benefit of symmetric key cryptography, that is fast communication, fast encryption, that is possible in the symmetric key cryptography, that is more for bulk encryption. Okay, so now let us see what are the main uses of PGP. The PGP is used for sending and receiving encrypted mails. It is used for verifying the identity of the person who has sent you this message, and it is also used for encrypting files stored on your devices or in the cloud. Okay, so encrypting mails, as we have already seen there. So as in the example above, the most people use PGP to send encrypted mails. In the earlier years of PGP, it was mainly used by activists, journalists, and other people who deal with sensitive information. So the PGP was originally designed, in fact, by a piece of and political activities named Paul Zimmerman. Today, the popularity of PGP has grown significantly as more users have realized just how much information corporations and their governments are calculating on them. Huge numbers of people now use standard to keep their private information private. Now let us see digital signature verification, how it is done here. So a related use of PGP is that it can be used for email verification. So if a journalist is unsure about the identity of a person, sending them a message, for instance, they can use a digital signature alongside PGP to verify this. Digital signature work by using algorithm to combine the sender's key with the data they are sending. This generates a hash function, another algorithm that can convert the message to a block of data fixed size. This is then encrypted using the sender's private key. The recipient of the message then can decrypt this data using the sender's public key. If even one character of the message has been changed in transit, the recipient will know. So this can indicate either the sender is not who they say are, or they have tried to fake a digital signature on that message as well. So I will cover this part. I am not going into detail into this digital verification here because I will cover it later. So let us see digital signature part there itself, and you will be able to understand. Here only you understand that this PGP is also used for digital signature verification, and it is also used for encrypting files. Okay, so the a third use of PGP is to encrypt files, because the algorithm used by PGP, normally the RSA algorithm, is essentially unbreakable. As I have told you, today you have studied the RSA algorithm and you have seen that this RSA algorithm is unbreakable till now. Okay, so PGP offers a highly secure way of encrypting files at rest, especially when alongside a threat detection and response solution. In fact, this algorithm is so secure that it has been used in high-profile malware such as the CryptoLocker malware. So back in 2010, Symantec acquired PGP Corporation, which held the right for the PGP system. Since then, Symantec has become the dominant vendor of PGP file encryption software through such product at Symantec Encryption Desktop and Symantec Encryption Desktop Storage. This software offers PGP encryption for all your files while also hiding the complexities of the encryption and decryption process. So this PGP is also used for encrypting files, and it is have been acquired by a commercial organization called Symantec, and that is using for encrypting files for storage, encrypted storage by the Symantec Corporation. So now let us see the pros and cons of the PGP. So PGP, pros is that it is extremely secure. The cons is that it is not user friendly. Pros is that OpenPGP is free to use, and cons is that it requires software. Pros is that improves cloud security, and cons is that no anonymity is being maintained in the PGP. So these are the pros and cons of the PGP. Now let us see some different PGP solutions. So the first solution is Outlook with GPG4o. So GPG4 is one of the most popular PGP solutions for Windows user and aims to integrate seamlessly with Outlook 2010 to 2016. Pros: GPG4 offers simple handling for emails and integrates well with Outlook. For most Windows user, it offers the easiest and most friendly PGP add-out on there. Cons: though GPG4 is built around the OpenPGP standard, which is open source and available for scrutiny, the add-on itself is proprietary. In addition, the business license for the add-on is really expensive. Now, Apple Mail with GPG tools. So the standard implementation of PGP encryption for Mac user is GPG tools. These are some of the use of the GPG, means how it is available, how you can use it. So it is available with Apple Mail with GPG tools. So Apple Mail with GPG tools is also using it. So the pros of this is that GPG tool integrates well with Apple Mail. It offers a key manager software that allows to use the PGP in almost any application, and a tool that allows To use the command line for the most common key management task, cons through GPT tools offers the easiest way for Mac users to start using PGP encryption using this encryption for the primary mail. Then Thunderbird with Enigmail, it also uses this PGP. So the pros is there. Enigmail has few key advantages. The first is that, like Thunderbird, the add-on is platform independent. Second on, the add-on is completely open source. This is open source, so anybody can use it. If you want to try PGP, you can use Thunderbird with Enigmail. So if you want to use the PGP, if you want how this PGP works, if you want to know the concept of this PGP, you can just download Thunderbird with Enigmail, configure it, and see how it is working. So secondly, the add-on is completely open source and is provided for free. It is also regularly updated, and the development team is quick respond to identify instances of malware. Cons, as with most open source software, Enigmail does not provide dedicated support as it is open source, so naturally this problem of dedicated support is there. On the other hand, the user community is large and active and has compiled a huge amount of reference material to get you started. Next is Proton Mail. So Proton Mail also uses PGP encryption. And next is Android and Fair Mail. So they also uses PGP encryption. Okay, so these were some of the use of the PGP and how it is available, means through which tools you can have used this PGP. So that was told to you. So that was pretty good privacy. Now let us come to the next protocol, which is based on this cryptographic principles. So that is your Internet Protocol Security, or this is IPSec. So it is the secure version of the IP protocol, which you use in the TCP/IP protocol. Okay. So now let us see a set of security protocol and algorithms used to secure IP data at the network layer. And IPSec provides confidentiality, that means encryption, integrity through hash, and authentication using signature and certificates of IP packets, while maintaining the ability to route through them existence. So it is a secure version of IP, and it is most widely used. This IPSec is most widely used to configure VPNs. Okay. So as I've told you, this IPSec, this is called Internet Protocol Security, and it provides you confidentiality by encrypting the data. Integrity, that means it checks the correctness of the data. It provides the authentication so that you can authenticate the data, and it also provides some anti-replay protection facility. So as a framework, IPSec uses a variety of protocols to implement its features, and I described here. So these are the protocols that are used in this IPSec. So first is encapsulating security payload, authentication header, ESP plus AH. The encryption algorithm there means IPSec protocols are encapsulating security payload, authentication header, and then encapsulating security payload plus authentication header. The encryption methodology or the encryption algorithms that are used here are DES, 3DES, and AES, and the authentication that is being done through hash function. So here we will use the hash function MD5 and SHA. So MD5 and SHA are used in IPSec protocol, and the mechanism that is used to share the key, that is Diffie-Hellman, that is DH1, DH2, and DH5. Okay. So where IPSec is used, so IPSec can be used on many different devices. It is used on routers, firewall, host, and server. It is used between two routers, or two routers to create a side-to-side VPN that bridges two LANs together. It is used between a firewall and Windows host for remote access VPN, and between two Linux servers to protect an insecure protocol like that. That is means it can be used between two desktop systems also to protect against this security leakage through telnet and other insecure protocol. Okay, so to establish an IPSec tunnel, IPSec uses a protocol called IKE, that is Internet Key Exchange, and there are two phases to build an IPSec tunnel, that is IKE phase 1 and IKE phase 2. So in IKE phase 1, two peers will negotiate about the encryption, authentication, hashing and other protocols that they want to use, and some other parameters that are required in this phase. And Internet Security Association and key management protocol session is established. This is also called ISAC MP tunnel or IKE phase 1 tunnel. So if you see here, this is IKE phase tunnel that is being built between the router R1 and R2. So the IKE phase 1 tunnel is only used for management traffic. We use this tunnel as a secure method to establish the second tunnel called the IKE phase 2 tunnel or IPSec tunnel, and for the management traffic light. So here it is your IKE phase 2 tunnel. So here is a picture of two routers that completed IKE phase 2. And for the actual data transfer phase, we use the IKE phase 2 tunnel. So one IKE phase 2 is completed. We have an IKE phase 2 tunnel or IPSec tunnel that we can use to protect our user data. So this user data will be sent through IKE phase 2 tunnel. Okay. So although this is shown diagrammatically like this, but actually it is a software. So in this, that means we have a second layer of protection that is called IKE phase 2 tunnel that is built in the IKE phase 2, and this is used for actual data protection. So your actual data is protected against IKE phase 1 tunnel, and that IKE phase tunnel is used for the management of the traffic. Okay. Now there are two protocols in IPSec. The first is your authentication header protocol, and other is ESP, encapsulating security protocol, as I have told you in this diagram. So this encapsulating security payload, IPSec protocol are encapsulating security payload, authentication header, and ESP plus AH. Okay. So here we will see authentication header and ESP encapsulating security payload. So the AH protocol only offers authentication and integrity, but ESP supports encryption also. That means if you are using the authentication header protocol of the IPSec, then your data, you can only have authentication and integrity, but you cannot encrypt the data. But if you are using the encapsulating security payload protocol of the IPSec, then you can encrypt the data also. So now let us see how this protocols works. So both protocols support two different modes, transport mode and tunnel mode. Okay. So what is the main difference between the transport mode and tunnel mode? The main difference between the two is that with transport mode, we will use the original IP header, while in the tunnel mode, we will use a new IP header. Here is an example to visualize this. So this is your original IP header. Okay. And in the transport mode, this original IP header will only be used. Only AH header will be put after this AH header. But in the tunnel mode, a new IP header will be created, and this AH header will be placed after this. And this original IP header will not be now function as a IP header. So in the tunnel mode, we create a new IP header and that guides the packet. And whereas in the transport mode, we have only the original IP header. And in the encapsulating mode also works in transport mode and the tunnel mode. So if this is the original IP packet, this is the IP header, this is the ESP header. And if you see here, now this data is encrypted. That means TCP header, data, and ESP trailer are encrypted. And now at the back, there is a ESP authentication also. So that means ESP protocol provides both authentication and the encryption. Whereas if you see the IP header, your data was in the original form. That means your data was not encrypted. So if you are using the AH mode, then your data is not encrypted. But if you are using the ESP mode of the IPSec protocol, then your data is encrypted. Again, I am repeating, if you are using the AH mode of the IPSec protocol, your data is not encrypted. But if you are using the ESP mode of your this IPSec protocol, your data is encrypted. And one more thing is that both this AH and ESP can be used in the transport mode as tunnel mode. In the transport mode, the original IP header that is of the IP packet is used. Only the AH header is appended after the original IP header, whereas in the tunnel mode, a new IP header is created and this AH header is appended after that new IP header. Okay, and similar thing happens in the ESP also. In the transport mode, your ESP header is added after the original IP header appended, and in the tunnel mode, a new IP header is created and your ESP header is appended after the new IP header. And next, this data is, if you see here what part are encrypted, so your IP, original IP header, TCP header, data, ESP trailer are encrypted, and this ESP authentication is built to authenticate also. That means ESP mode provides both authentication as well as data encryption, whereas AH mode only provides authentication and data integrity. Okay, and next we can use a combination of AH and ESP. So this is your ESP, that means it provides both authentication, integrity, and protection. So this is how this is IP header, AH header, ESP header. So it is encrypting also, it is authenticating also. So we can use the combination of AH and ESP. So this is the transport mode of the AH and ESP. So IP header, AH header, ESP header, TSP header, data and ESP header. And this is encrypted. If you see this part, I'm doing this. So if you see these here, TCP header, data and ESP, that means here both authentication and encryption is there. And this is the tunnel mode. So in the tunnel mode, your new IP header is created, AH header is appended after that, ESP header is appended. This is for authentication, and this IP header, TSP header, data, ESP trailer, all are encrypted. Okay, so this is how we have seen the modes of the IPSec. Now let us see how IPSec, what are the steps of the IPSec. So we have the following steps. Entire process of IPSec consists of 5 steps. Initiation. So first the connection is initiated, then IKEY phase 1 is start. In IKEY phase 1, we negotiate a security association to build the IKEY phase 1 tunnel, as I have shown you in the previous slides. And in the IKEY phase 2, within the IKEY phase 1 tunnel, we build the IKEY phase 2 tunnel, and that is for the actual data transfer. This protects the data. So data transfer, we protect user data by sending it through the IKEY phase 2 tunnel, as I have told you. And termination, when there is no user data to protect, then the IPSec tunnel will be terminated after a while. And next is your internet key exchange. Okay, so this protocol is also there in the IPSec. So internet key exchange is one of the primary protocols for IPSec, since it establishes the security association between two peers. There are two versions of IKEY, IKEY version 1 and IKEY version 2. So this IKEY version 1 was introduced around 1998 and superseded by IKEY version 2 in 2005. There are some differences between the two versions. What are the differences? IKEY version 2 requires less bandwidth than IKEY version 1. IKEY version 2 supports EAP authentication next to pre-shared keys and digital certificates. IKEY version 2 has built-in support for net traversal, and IKEY version 2 has built-in keep alive mechanism for tunnels. Okay. So IKEY has two phases, IKEY phase 1 and IKEY phase 2. So IKEY phase 1, in IKEY phase 1, what happens? Negotiation. In the negotiation, hashing, we use a hashing algorithm to verify the integrity. Then authentication happens. Each peer has to prove who is, and then the Diffie-Hellman algorithm is used. That is the strength of the key that is used to key exchange process. And lifetime, how long does this means? IKEY phase tunnel 1 is created in this, so it will determine the lifetime. And then encryption, what algorithm do we use? For example, DS, 3DS or AES, means which algorithm we will use for encryption. And then in step 2, the Diffie-Hellman key exchange, that means the key is exchanged. So once the negotiation has succeeded, the two peers will now know what policy to use. So they will now use the DH group that they negotiated to exchange the key, that is keying material. the end result will be that both peers will have a shared key. The last step is that two peers will authenticate each other using the authentication method, and they agreed upon on the negotiation. When the authentication is successful, they have completed IKEY phase 1, 2, and the end result of IKEY phase tunnel, which is bidirectional. That means both peers can send and receive on this tunnel. There are 3 steps that can be completed using 2 different modes: main mode and aggressive mode. Main mode uses 6 messages, while aggressive mode only uses 3 messages. So I am not going into detail of this message. Now let us see IKEY phase 2. So in the IKEY phase 2, they will now negotiate about IPSec protocol, means what mode of the IPSec protocol they will use. Either they will use AH or ESP. Then the encapsulating mode, that means they will use AH or whatever the protocol they are using, AH or ESP, they will use in transport or tunnel mode. What will be the encryption algorithm they will use for actual data transfer, and what will be the authentication algorithm they will be using, MD5 or SHA, and lifetime. How long is IKEY phase 2 tunnel valid? Means how much this second tunnel, which is created for actual data transfer, how much lifetime, what will be the lifetime of this tunnel, and then optional D8 exchange, it is used for perfect forward secrecy. So this is whole about the IPSec. So if we summarize, IPSec protocol is 2 modes, that is authentication header and encapsulating mode. In the AH mode, we have only AH and integrity that is verified. There is no data encryption, whereas in the encapsulating security mode, we have data encryption also. And this encapsulation mode is in transport or tunnel mode. In the transport mode, the original IP header is only used, whereas in the tunnel mode, new IP header is used. And then we have some phases, IKEY phase 1, IKEY phase 2, through which this data is transmitted. Okay, so this is how this data is transmitted in the 2 phases, IKEY phase 1 and in IKEY phase 1. IKEY phase 1 tunnel is built, and this tunnel is used for management of the traffic, whereas the IKEY phase 2 tunnel, that is used for data protection, and it is used for actual data transfer. Okay, so this is whole about the IPSec protocol. Now let us see what our crypto systems are built up of. You have studied many applications of cryptography, so let us now summarize. So a crypto system is made up of at least the following: software, protocol, algorithms, and keys. This you have seen in all those protocols in which security protocol in which cryptography was applied, whether it was SSL, whether it was PGP, or whether it was IPSec. Okay, and services of crypto system, naturally, as you have seen, that crypto systems provides confidentiality, integrity, authentication, and non-repudiation. Okay. So you are clear: confidentiality, that is encryption; integrity, that is the correctness of the data; authentication means you can verify the identity of the user. And this you have seen, the digital signature principle of the public key crypto system, that is used for authentication and the non-repudiation part. And now let us see how digital signature is created, because in the next session you will see the demonstration, actual practical demonstration of that. So now let us see digital signature for a message. So suppose this is a message, how you will put the digital signature on this message. So you will calculate the hash value of this message. You will encrypt that hash message, means you will encrypt this message digest that is calculated of this message with your private key, and then you will append this message, this encrypted message digest with this message. And now you will send it to the recipient. Now what recipient will do? Recipient will take this message plus encrypted message digest. It will calculate the hash value of the received message, and then it will decrypt this hash message using his public key, because the public key of this user is available worldwide through public key infrastructure. So he will decrypt this message digest using the public key of this user, and now he will compare both this both this hash values. If the both hash value matches, that means it is sent by this sender only, and the message has also not changed in between. So this is, so I have told you that authentication and non-repudiation both are ensured here. So authentication and the non-repudiation are ensured using the digital signature for a message. So again, I am repeating, this is the message. You are calculating the hash value of this message, and you are encrypting with the private key, with your private key. With your private key, you are encrypting this hash value, and you are appending this encrypted hash value with your message. Okay, and when the recipient receives this message, he calculates the hash value of the message using the same hash function. And now he has the encrypted message digest. So he will decrypt this encrypted message digest using the public key of the sender. And now he will get two hash values, one from the message and one from this encrypted message digest, and both he will compare. And on comparison, if he finds that both match, that means the authentication and the non-repudiation. That means the same this user has sent this message, and it is also verified that this message has not changed in the middle. So this is for the digital signature message. One thing you may ask, this message is the original message is sent in the plain text format. So how to protect that message also? So for that, a extra layer of envelope could be created. That means this message plus this encrypted message digest could be encrypted using the public key of the recipient. Okay, so when the recipient receives it, it first opens the envelope. That means it first decrypts the encrypted thing which he has received, and when he will decrypt that, he will get the this message plus encrypted message digest. So in this way, this original message will also be protected. Okay, so nobody can read this message or like that. So that means encryption can or confidentiality could be also maintained with this digital signature. Means you can put the digital signature also, and you can maintain the confidentiality of your message also by creating an extra envelope over this digital signature of the message. Okay, so this is whole about the today's part. I think mine was up to 4:45. Okay, so I think I have finished most of the parts. So now I will give time to the questions. Okay, because I finished the lecture. Okay, so now I will give 15 minutes to the questions. So now you can ask questions on the chat box, which I will reply, because there were 3 hours of this lecture conducted. So you may have a lot of questions that I will reply. Atul?
Yes, sir.
Please ask participants to send messages in chat box so that I can reply.
Everyone, please make your query in the chat box and question and answer box. If anyone have any question, please write in the chat box.